Hey guys, today I want to give you an introduction to the chain rule. So the chain rule is what we use when we're differentiating the function of a function. So let's say that we have an equation y equals sine of x squared plus 3x. So if we look at the right hand side, then what we have is a composite function. We have a function x squared plus 3x inside of another function sine. So in order to differentiate composite functions, then what we need to use is the chain rule. So dy by dx is equal to dy by du multiplied by du by dx. So you're probably wondering, why is there a u in this equation and where does the u come from? Well, u is a variable that we define, and we always define it as the innermost function. So in this case, the innermost function is x squared plus 3x. Now we can differentiate this equation with respect to x, and we'll end up with du by dx. So if we differentiate u with respect to x, we get 2x, the derivative of x squared is 2x, plus 3, the derivative of 3x. So we've got du by dx, and now we need to work out dy by du. So in order to find dy by du, we need an equation of y in terms of u. So if we look back at our first equation, y equals sine of x squared plus 3x, remember we defined u to be this inner function, so y is equal to sine u. Therefore, if we differentiate this equation with respect to u, then we get cosine u. And so now we have du by dx, we have dy by du, so we can plug it in the formula in order to find dy by dx. So dy by dx is equal to 2x plus 3, that's du by dx, multiplied by cosine u, which is dy by du. Now we're not done yet. The last thing that we have to do is we have to replace the u in this equation with what we defined it to be originally. So remember, u is x squared plus 3x, therefore dy by dx is equal to 2x plus 3 multiplied by cosine of x squared plus 3x. And so this is the derivative of sine x squared plus 3x. Alright, so let's go through a couple more examples so that you become a bit more familiar with when you need to be using the chain rule. So let's say y is equal to x cubed minus 1 to the power of 7. Again, here we have a composite function because we have the inner function x cubed minus 1 and we have an outer function raising that to the power of 7. So again, the first thing we need to do is we need to let u equal the inner function, so u equals x cubed minus 1. So if we differentiate with respect to x, then that's going to allow us to find du by dx. So on the left we get du by dx. On the right we're going to have, we're using the power rule on x cubed, bring the power to the front and then decrease the power by 1 is going to give us 3x squared, and of course the derivative of minus 1 is just 0. So du by dx is equal to 3x squared, and so the next thing we need is dy by du. So in order to find dy by du, we need an equation of y in terms of u. That equation is y equals u to the power of 7, because remember x cubed minus 1 is what we defined to be u. So y equals u to the power of 7. If we differentiate this with respect to u, that's going to give us dy by du is equal to 7u to the power of 6. Again, we're using the power rule. And so now we have du by dx and we have dy by du. So we're ready to find dy by dx. So we get 3x squared times 7u to the power of 6. This is du by dx, this is dy by du. And so the last thing we need to do is we need to replace u with what it was originally. So we get 3x squared times 7 x cubed minus 1 to the power of 6. And then the last thing we do is simplify, so we get 21x squared times x cubed minus 1 to the power of 6. Okay, so let's do another one. Y equals e to the sine x. So again, we've got a composite function. We have the exponential function combined with the sine function. So in order to find the derivative of this composite function, we need to use the chain rule. And in this case, sine x is the inner function. So we can let u equal sine x. If it were the other way around, then we would have y equals sine of e to the x, and in that case, we would want to set u to be e to the x, but this is not the case. We have sine x as the inner function, and we have the exponential function as the outer function. So u equals sine x, so du by dx is the derivative of sine x with respect to x, and so hopefully you remember that the derivative of sine x is cosine x. So this is du by dx, and in order to find dy by du, we need an equation of y in terms of u, so y equals e to the u. Now we can differentiate with respect to u, and the derivative of the exponential function is itself. So dy by du is e to the u, therefore dy by dx is equal to dy by du, which is e to the u, multiplied by du by dx. And again, the last thing we do is substitute in u what it was originally. So we get e to the sine x times cosine x, or cosine x e to the sine x. Alright, so let's do one more example. Let's say y is equal to natural log of x squared. So again, we have a composite function. We have ln x inside of the square brackets here. So in order to find the derivative, we're going to need to use the chain rule. So I think it's quite clear here that the inner function is ln x. So we need to let u equal ln x. And so if we differentiate this with respect to x, the derivative of natural log of x is 1 over x. So du by dx is equal to 1 over x. So now we need to find dy by du, but first we need to write y in terms of u. So if u is ln x, then y is equal to u squared. And therefore, if we differentiate this with respect to u, we get dy by du is equal to 2u using the power rule. And so now we can plug this in to our equation to find dy by dx. So dy by dx is equal to 2u. This is dy by du multiplied by 1 over x. And that's du by dx. So replacing u with what it was originally is going to give us 2 ln x over x. And so the derivative of ln x squared is equal to 2 ln x over x. Hey guys, thanks for sticking around. I hope you learned something new from the video. And comment down below what video you want me to make next, and I'll see you next time.